Your true core self, your essence, your vital force, your will, drive, soul, spirit, agency, the thing you've got that leaves your body at death. What is that thing? To simplify and get to the bottom of it, I'll call all of us living beings selves. A tree's a self, a bacterium's a self, an extraterrestrial, if we ever find one, is a self. Weird? Yeah, go with it. And what do all selves do? We try. Above all, we try to survive and reproduce, or else there wouldn't be selves here 3.5 billion years after the origins of life. Selves try, non-selves don't. We can give selves and trying all sorts of names, but naming doesn't explain anything. Call it a soul if you're spiritual. Call it agency if you're scientific. I don't care what we call it. We still got to explain it. How to explain selves and trying. What makes a self a self? What makes us try when other things don't? Saying what it does doesn't explain it either. The self tries, the soul cares, the will motivates, whatever. That doesn't explain it any more than saying a stove heats explains how it does it. And saying where it happens isn't explaining it either. Consciousness is in the brain, soul is in the heart, appetite is in the stomach, motivation is in the meat. Go ahead, put your finger on consciousness, soul, appetite, motivation. No one ever has. Sure, selves happen in biochemistry, but biochemistry isn't the self. The biochemistry is all still there after a self dies. So what the heck is a self? We can settle for it's a mystery, or make up some magical metaphorical fiction about a higher power breathing soul into meat, or natural selection trying to design us. It doesn't. Metaphors are fine for every day, but won't do for science. Harvard Berkeley neuroscientist and bioanthropologist Terry Deacon has a wildly original, yet thoroughly scientific new angle on what selves and trying are and how they could get going in a universe that's not trying to do anything. I've worked with Terry for 20 years, and here I'm going to give you the short version of his theory to chew on. We've been going at the mystery of selves and trying all wrong. We've been focused on finding that special thing that makes selves do what they do. We should be focused instead on how selves prevent themselves from doing other things. To keep going, you prevent your own failure to keep going. To stay alive, selves prevent death. Here we'll start by honing in on minimal trying, identifying the work that all selves have to do to keep from dying. Then we'll look for how we do it by keeping ourselves from doing other things. Then we'll look for how selves and trying could emerge from basic chemistry. 3 steps. Identify what every self has to do to keep living, explain how they prevent their own dying, explain how that starts from basic chemistry at the origin of life. Okay. First step, identify what every self must do. Everything in the universe breaks down over time. That's about as fundamental as science gets. Given time, any sorted, ordered, regularized thing gets messed up or mixed up. You see it everywhere. You fix things, they break down. You wind things up, they wind down. You sort things out, they get mixed up. Things fall apart. You've got order, and then you've got messed up shit. With time, shit happens. That's the second law of thermodynamics. Selves somehow work against it, trying to keep it together when non-living things don't. Selves regenerate in the face of second law, shit happens degeneration. It's not that we're tough. Just look how fast we degenerate when selfhood ends at death. Rocks degenerate slowly, but they don't try to prevent their own degeneration. They just happen to be durable. We selves do ongoing work to prevent our own degeneration, an ability we pass on to offspring. So, a first distinction. There's stuff that just exists as long as it does, and then you've got selves, things that try to persist. There's passive existence, and there's self-regenerative existence. Big difference we're going to explain here. To self-regenerate, here are the 3 kinds of work selves must try to do. Self-repair, regenerating what degenerates, fixing, healing, repairing ourselves. Self-protection, regenerating a boundary, for example, cell membranes, bark, your skin, protecting us from external forces that would degenerate us. Without containment, we degenerate by spilling out. Self-reproduction, regenerating offspring that also self-protect and self-repair. Done with step 1. Selves self-regenerate by self-repair, self-protection, and self-reproduction. Work done by the self for itself, fit to its circumstances. On to step 2, where we flip the question, asking how selves prevent themselves from doing other things instead. That's a bit of a brain twister at first, but you'll get it. After all, you do it. Nothing we selves do ever defies the laws of nature. Everything about us is strictly chemical cause and effect. What then explains why we act so differently from chemistry? Chemical reactions degenerate, but selves don't. Selves have carried on for eons. The answer, overlooked for millennia, is simple. Sure, we're chemical cause and effect, but not just any. In chemistry, anything goes within natural law. We selves limit chemistry's anything goes down to what keeps us going. Instead of looking for what's added to chemistry to make us regenerate, look for how we prevent our degeneration. Living is death prevention, a constraint on what happens. You know all about preventing the useless to do the useful. To do what you want, you prevent yourself from doing what you don't want. All effort is like that. Our limbs have a wide range of motion. Our focused effort is a matter of limiting that range of motion, reducing the possible to the useful. Likewise, we could say anything, but we reduce the vast possible down to what we're trying to say. Reducing the possible down to the useful. What's our core focus? We do work for a chance to keep working another day. You work for food, energy so you can do focused work to repair what breaks down and to keep a roof over your head, for protection and maybe to pass on those abilities to offspring. Apply that to all selves and you've got self-repair, self-protection, and self-reproduction, all by preventing their own anything-goes dithering. Okay, done with step 2, explaining how selves try to stay alive. All selves prevent their own degeneration in ways that maintain their ability to prevent their own degeneration. That's what it means to be alive. It's not something added to chemistry, it's self-regenerative self-constraint. The failure of self-regenerative self-constraint is death. The chemistry is all still there, even still organized for a while before degenerating, but not for long since there's no longer any self-constraint regenerating it. On to step 3. Life had to start like that too. All of what's chemically possible reduced somehow to the useful. Reduced by evolution? No. Evolution doesn't explain selves, just how they're honed. Obviously, evolutionary theory is well established, yet the origin of life has remained a mystery. By definition, selves had to start by accident. Trying emerged by happenstance, not by trying. You can't say trying started when something tried to make it happen. Selves emerge when somewhere all of the chemically possible reactions happen to get constrained or reduced down to reactions that prevented their own degeneration. So how does constraint happen? How does something that was possible become unlikely, thereby making other possibilities more likely? We'll start with a familiar kind of constraint. When we think about constraint, we usually imagine hard imposed barriers. A riverbank that prevents water from spilling just anywhere. A hallway's walls that keep you walking in 2 directions only. Plastic insulation that keeps electrons running down wires. Guardrails that keep us from going off the road. An engine cylinder that prevents gasoline explosions from expanding in all directions. Engineers impose constraints. They're wranglers, corralling energy, constraining or channeling it into useful work we want. But selves aren't engineered. There's also emergent constraint. It comes in two flavors. One, called self-organization, was discovered about 70 years ago and has been a hot topic in science ever since. Self-organization is a lousy name for it because there's no self trying to organize anything. We'll call it emergent regularization. Emergent meaning that it's a constraint that arises from dynamic interaction. I'll explain it next. The other kind of emergent constraint is the one Deacon discovered, emergent self-regeneration. That's the punchline here. Wait for it. Emergent constraint is different from imposed constraint. Hall walls will constrain you, but so will walking through congested foot traffic. As you thread your way through the congestion, others thread around you. You all take paths of least resistance. Eventually, traffic simplifies into constrained pathways, people filing through taking regularized paths of least resistance that emerge throughout the congestion. That's emergent regularization. Self-organization or emergent regularization explains a variety of phenomena, including whirlpools, chain reactions, and crystal formation, none of which are self-regenerative. They aren't alive, aren't selves, aren't trying. They don't self-repair, self-protect, or self-reproduce. Traffic clears faster when people file through on regularized paths of least resistance. Likewise, bathtubs drain faster when there's a whirlpool at the drain. Chain reactions consume all the nearby fuel and then peter out. Deacon, though, shows how two emergent regularization processes, chain reaction and crystal formation, can end up synergistically coupled, each constraining the other, yielding emergent self-regeneration, selves that try to self-repair, self-protect, and self-reproduce. To get it, here's all you need to know about chemical chain reactions and crystal formation. A chemical chain reaction is like a population explosion of molecules, not selves. It starts when a small concentration of catalyst molecules, say of two kinds, imagine them like male and female, transform reactant molecules, fuel, into more catalysts, transforming more reactants into still more catalysts, on and on until the reactants are depleted. It's an example of emergent regularization because it generates a fleeting concentration of catalysts. Fleeting because nothing holds them together. The concentration dissipates. Crystal formation generates order, molecules lining up, forming solids, including shells or tubes, again passively, doing nothing to regenerate their order, just slowly breaking down. Okay, finally ready for the origins of selves from basic chemistry. Picture a chain reaction that generates a population explosion of catalysts, but also crystal shell molecules. Shell molecules coalesce into shells that happen to enclose a cluster of catalysts, sort of like seeds. When the shell happens to break apart in the presence of reactants, the chain reaction resumes, generating more catalysts and shell molecules. Terry calls this model for the origins of life an autogen, a self-regenerator. With selves like us, there's synergy. Our parts are means to each other's ends. Lungs help heart, which helps lungs, etc. How does that start? With the autogen, chain reaction and shell formation processes are means to prevent each other from ending. By itself, a chain reaction is likely to run out of fuel and then dissipate. But with the autogen, before it does, the shells encapsulate a cluster of catalysts big enough that the chain reaction is more likely to resume, less likely to dissipate. Likewise, by itself, crystal shells degenerate and shell molecules drift away, but the chain reaction replenishes the shell molecules, regenerating new shells. Look what you get. Self-repair and self-reproduction. When a seed breaks and catalysts spill out, the chain reaction resumes, generating more seeds. That's it trying to prevent degeneration. Self-protection. The shell prevents catalyst molecules from just dissipating. All known selves are continuously enclosed in protective covering. Autogens aren't. When a seed is broken, the autogen is just exposed catalysts, generating more catalysts and shell molecules, nonetheless preventing their own dissipation since the chain reaction generates more seeds. The autogen thus has two phases, sometimes closed, dormant seeds protected from degeneration, sometimes open, regenerating more seeds. Having two phases is the only way to solve, at the origin of selves, a problem for all us selves. We all have to be open to get energy for our work to self-repair and self-reproduce, but we also have to stay closed to protect against degeneration. All known selves achieve selective interaction by means of highly evolved pores, orifices, and semi-permeable membranes. First selves haven't evolved yet, so have to achieve selective interaction by accident. And they're not going to chance on some lucky membrane that protects against the bad stuff, but lets in the good stuff. The autogen gets selective interaction by being sometimes closed, sometimes open. So what then is the life force, soul, spirit, will, agency, drive, motivation that we find in selves but not in inanimate things? It's neither magic nor mechanics. Deacon describes it as a constraint that channels energy into work that regenerates the constraint. You're still chemistry. You don't defy natural law. And you're not some supernatural thing either. You're not just any chemistry. You're chemistry that keeps preventing its own degeneration. To understand us, it pays to start at the beginning, uncluttered by our highly evolved bells and whistles like consciousness. Start with first selves, as we did here. Read more about the autogen, the logic behind it, and its implications in my new book, Neither Ghost Nor Machine, The Emergence and Nature of Selves. Or get more information at our website, teleodynamics.com. And thanks for watching. I know it was a lot, but we're solving a mystery that has dogged scientists for centuries and philosophers for millennia.